So this screencast here is for our force diagrams where we're going to 1. Identify the system, 2. Draw the free body diagrams, 3. Draw in these equality marks on the free body diagram, and then 4. Get the sum of the forces. That's where you're adding the forces to get to the net force in the x and the y direction. So what I mean by 1. Identify the system is we're going to identify the system by putting these dash marks all around the object of interest. So that way we're encapsulating everything that the system is involving. So this cat is on the system, is this part of the system. There's the surface that the cat is on, and it's in this gravitational field of Earth. So we have the system. Then we're going to draw the free body diagram. We're going to simplify the cat down to a box. With the cat as a box, we point a point at the center. That's the center of mass for the cat. And this cat has a force acting down. This force is the force due to gravity. We know this as this m times g, where the g is that 9.81 newtons per kilogram, 9.81 meters per second squared. The reason why this cat is not accelerating down is because it's on the surface. The surface has a force up, being this normal force. And the cat then allows us to see that there is these equality marks. The force down is going to equal to the force up. The free body diagram shows then that this normal force up has an equal force that is pointed down, this gravitational force down. They equal to one another. So if this gravitational force was 10 newtons, the normal force is 10 newtons. If this gravitational force is 20 newtons, normal force is 20 newtons. Now we get to the sum of the forces in the x and y direction. This is where we're going to add them up. So we can sum the forces in the x direction, that's going left and right. In the x direction, there's nothing. So this equals to ma in the x, which is equal to 0 newtons. That's what the net force tells us to do. You add all the forces, and there's nothing going left and right, and you set it equal to ma, and it equals to 0. So now we're going to get the sum of the forces in the y direction. Sum of the forces in the y, you get the normal force up, and you get this gravitational force down. So we're adding these forces. Normal force is up, so it's positive. Gravitational force is down, so it's negative. Negative mg. Set this equal to ma in the y. These forces are balanced. The balanced force up and down. So this equals to 0 newtons. And we know this because the cat is motionless on the rug. We can do an example as we look here for the skater, where we see that this skater is going at a constant speed, so that tells us about the system. So we see the system here. The system is a skater. I'm including the ice that the skater is on, the free body diagram. So once again, gravitational force down, normal force up, and this skater is going at a constant speed, so these forces are balanced, and it's saying that in this, we can assume that this is frictionless ice. So we can get the sum of the forces in the x direction. There's nothing there. So we set that equal to ma in the x. No forces going left and right. Get the sum of the forces in the y direction. Normal force up minus this mg down. And this equals to ma in the y. And that equals to 0 newtons as well.